Okay, so today we will start with some concepts or like from the topical MCQs and topicals theory section because work energy questions you find different section like in forces, elastic deformation. They ask about the concepts of energy in other chapters also because energy is like the natural thing whenever we apply force, whenever we are doing some work. So they will always ask about the concept of energy, right? So that's why the concept of energy is like included in every section in every chapter. So it is like a very journal basic concept. Okay. So it is not compulsory that always they will ask about the specific question for energy. Sometimes they just add those question with motion chapter, with forces chapter. And we also solved some questions from the previous topic, and we found that most of the questions include the section from work energy power section. So that's why this chapter and this concept is very much common in other chapters also. Okay. Okay,
Okay.
we start with the first question. So in first question, they are asking some sources of energy used to produce electricity and may run out in the future. So some sources will run out in the future. It means that are non-renewable, right? Because
So can I
renewable,
try?
yes, you may mark the answer on the screen.
How do
You
I mark it? Okay.
so
So you
basically,
didn't enable annotations.
yes. Okay, let me enable that. Annotation is available. A 1 minute. Okay, now you may check.
Yeah, now it is.
So you need to underline the two sources of energy that are likely to run out first before the others. Okay, so one of you just send me in text or coal and oil. Okay, so all of you are agreed on coal and oil, right? Because solar, tides, wave, wind
Yeah.
are natural, right? So there is no limit. We are not able to identify their extreme limits that when these sources will be run out. So coal, oil is the right one. Okay, and next there is a steam coming from some setup into the turbine, then there is a generator. And if you remember this whole energy flow diagram, so we already discussed this diagram with the reference of nuclear power plant, right? And what is the question they are asking in this? Thermal energy is given to the water as it passes through rocks underground. Okay, so this time they are using geothermal energy, right? So they are
Yeah.
using energy from the soil and describe the process by which this thermal energy causes the turbine to run. And question is for 2 mark only. So you may just take the reference from the diagram first, that what are the features and what are the components installed in the mechanism. And then you have to answer this question. Question is for only 2 marks. So you need to explain two valid points that will support your answer for 2 mark. Easy one or difficult one?
So I didn't revise, so I'm thinking of how to
Okay.
put.
Okay, so basically we are taking thermal energy from the rocks underground, right? The geothermal energy.
Yeah.
Okay, Zohaib raised hand. Okay, Zohaib, if you want to add something, you may add.
Sir, the thermal energy turns the water into steam, and the
Okay,
steam passes through the tunnel and turns the generator,
okay.
or
So
turns the
basic,
turbine.
yes. So that is the process that Zohaib mentioned. And you, I know that you all know about the process, right? But now they are asking about the process, so you already know the process. So that is the answer you need to write in your statement form in the question, right?
So can you write it?
Okay, I will write the question. I was waiting that if someone is still thinking and want to answer, so I'm just waiting for that. Otherwise, no issue. Okay, so basically, or the rocks which are underground. So underground rock provides thermal energy to the water, because in the diagram you can see that they are using the reference of steam, and it's depend upon the mechanism that either we are using the nuclear power plant or we are using the geothermal energy. So in energy flow diagram we just use different source, but still concept remains same. We are getting same steam, same turbine, same generator. Okay, so basically we are getting thermal energy, supplying energy to the water. Geothermal heats water up, forming steam. Steam causes the turbine to run. Yes, your answer is also right. So water converts into steam. And basically, no, that was right. And just write one more specification of the steam, in the sense that steam provide like mechanical energy. Okay, basically we are converting now thermal energy into the mechanical, because our main purpose to just move that turbine is because the movement of the turbine is like kinetic energy. And we already discussed in flow diagram that actually we are providing mechanical energy, right? Helps the turbine to move. So basically we are converting into mechanical energy. Okay, try to write the type of energy also. Geothermal energy heats water, forming steam, the turbine to run using mechanical energy. Yes, Umair, your answer is also right. So basically there are multiple ways to phrase your answer. It's up to you. But only the important thing is that there are two concepts. Steam basically provides thermal energy, and we are using that thermal energy to run that turbine, which is known as mechanical energy, right? So that is the two basic terms they want in your answer, because that's why they are just giving you 2 marks. Okay, because sometimes the student got confused that what type of source we are getting from the rock. So basically we know about geothermal. So geothermal means the heat energy we are getting from underground rocks, right? Okay, just skip this question for time being. We will discuss that in the next section of thermal physics section. Okay, specific heat. Skip this topic for the time being. This is related to the work done. So a woman does work as she raises a flag by pulling downwards on a rope. So diagram is in front of you, so you can easily identify what is actually going on. And the next part is define what is meant by work done. And you all know about work done. What is the definition of work done?
Force into distance.
Force into distance or displacement. Basically, they are asking for 2 mark, right? So if you write force applied per unit distance, okay. So basically, force into displacement or force into distance gives you the concept of work done. Product of force and distance, yes. So basic definition is right, and you know that they are giving 2 marks, so for definition uh, they will maximum give you 1 mark. So how you will get 2 marks? So basically, if you remember, we discussed the concept that if we apply force, so body should move in the same direction. If you remember, we discussed the concept of maximum work done and minimum work done, right? I
Yes,
think
sir.
we discussed in different slide. So the next mark is for you can just simply write product of force and displacement or distance. And second point is for the direction, right? The concept of direction. Yes. If you want to explain in detail, it's up to you. Otherwise, if you just write product of force and displacement, so that is also fine.
So displacement is done in the direction of the force, right?
Yes. And displacement. They want to ask you about the concept of direction in the question also, right? And the next part is, and why they ask this, you will got this concept in part C, because they just connect one part with the other one, and mostly 99% hint will you will find in your own question. So it is very important to keep a note of everything in your question. Second part is very easy. Mass is given, height is also given, value of g is given, and you need to find out gravitational potential energy. Okay, Omer just write in the chat gp is equals to mgh. Okay, very good. So basically, second part is very basic, very simple, free marks, like free 2 marks you will get. So we are talking about potential energy basically. So the formula for potential energy is gh. Mass is 0.35. 60 multiplied by 0.35, you will get 21, right?
Yeah.
Okay, so you are getting 21 joules. Now the next part is very important. Question is for 2 marks, and they are asking
So I
suggest.
don't understand the question.
Okay, I will give you the hint, but they are asking. So you need to suggest. So 1 mark for suggestion and 1 mark for explanation. So they are
Yeah.
asking a reason why the work done on the rope is larger than the value calculated in B. So basically, we calculated the value in B.
Wait, so can you show the full question?
Okay.
Zoom out or something.
Basically, this is the full question, and in diagram, if you want to take the reference, so you take the reference from the diagram, because first part is just definition. There is nothing uh hidden in that.
Yeah, okay, there's no, okay,
Okay.
yeah.
So basically, we're asking that you calculated the value 21 joule, and we know that law of conservation of energy, that energy can neither be created nor it can be destroyed, right? So they are asking that your work done should be equal to 21 joules, right? Because energy remains conserved. But they are asking why the work done on the rope is larger than the value we calculated in part B. This is part, that is 21 joules. In simple words, they are asking that why your work done will be greater than 21 joules. I will again show you the diagram, the hint from the diagram. Mass of rope is greater than mass of the flag. Okay. And basically, you need energy to do work, right? So basically, if you just want to push or drag the box on the ground floor, if we include all the forces, right? Because now they are asking about the reason why your work done will be greater. So if you include all the quantities, all the forces that you studied till now, so what do you think that why we have to do more work? Basically, one thing is we are doing
It's
work.
weight.
Yes, basically one quantity is of weight. So basically we required additional force to lift that flag. Secondly, the weight of the body will act in downward direction. Okay, and you need to lift that flag in upward direction. So your work will be in upward direction. And one more thing, when you are just pulling that rope, so you will also get another form of force, another type of force. Can you identify that force?
Wait, is it like air
Tension or
resistance
something?
or something?
Tension.
Friction, air resistance.
Yes, friction and air resistance. So basically we are getting friction in rope, because normally you know that if they are asking without the reference of friction, so they just mention in the question that friction is negligible or just ignore the friction, right? So in this question they are asking why, so basically they are going to ask you about the concept of friction also, because when you are just pulling that rope, so definitely there will be a force of friction, right? So when you try to write this answer, so 21 joule is the work done that we require to pull the flag. But there are some additional forces like friction, air resistance. So that will also increase the resistive force. So to overcome that resistive force, you need to do more work, right? So that is the problem that you have to cover in this situation. So now anybody wants to answer?
Wait, so can you repeat what you were saying?
I repeat.
Yeah, can
So
you repeat what you
basically,
were saying?
okay. So basically, you mentioned that weight of the body will be in downward direction. Okay, that's right.
Yeah,
Secondly, you are doing work in the opposite direction. Okay, so
yeah,
the third thing is that is the problem is that there will be a force of friction also, right? So
yeah.
friction is basically the hindrance, the resistance in the path of the work done, right? So we have to overcome that friction to move that flag up. If we apply the same force, so you know that when resultant force will be zero, so body will remain at rest, body will not move, right? If book is lying on the table, so weight and normal reaction is equal and opposite. If you want to lift that book, so you have to apply additional external force, right? That will help you to lift that book in upward direction. So basically, external forces like friction and air resistance in opposite direction. And the
So
last
does
thing
the
is,
friction increase as the work done increases or something?
yes. Basically, if you just
Oh, okay, okay.
something with greater force, so definitely you will get more friction. Just like when in a start, if you want to push your car, if you are running out of fuel and you want to push your car, so initially you are getting very high friction. And once the tire starts to roll, so then it will be easy to push that car, right? So to overcome these forces, Okay, so for that purpose, we have to apply additional force to overcome these resistive forces. So that's why your work done will be greater than
So the
20.
first point is the suggestion, the second part is the explanation.
Yes.
Okay.
So basically, question is not purely related to the forces. So they are just asking about the names. So if you just include the name of resistive forces, so that will give you the marks of the question, right? Okay, we already did the question in the chapter of elastic deformation, because in this question there is one part which is related to the energy. Okay, so just skip this question for the time being because we already discussed. Okay, question number 5. Just read the question because this is theoretical and Zohaib wants to answer. Okay, Zohaib, you may answer.
So renewable energy source is when the energy can be replenished at the rate it's being used.
Okay, good. So the first thing is you have to define the renewable energy source, right? And question is for 1 mark. So simply you just need to copy paste the definition, right? That we already discussed. So no issue in the first part, right? So basically, renewable energy is like
Renewable energy source is an energy source which is produced as much as it's taken away from the environment or something like that.
so we already discussed about the definition. So you may just take the reference from that definition: energy derived from natural sources that are replenished at a higher rate.
Oh, at a higher rate. Okay.
Okay. So that's why I'm not writing in detail again. And it will not run out just like the other sources. And state the name of one other renewable energy source. So one is already given in your question, the example of the wave, and you have to mention one other renewable energy source that is not given in the question. In your question, they
Wind
are
energy.
Solar energy.
yes. So basically, in question,
Oh, it's already given. It's
not
already given.
green energy, right?
Uh,
Solar energy and one you mentioned
Solar energy. Yeah, solar energy. So does
Also,
hydrogen,
practical
oxygen, does hydrogen fuel cell work?
hydroelectric.
No, hydrogen.
Hydrogen in the sense,
nuclear.
The fuel cells.
yes, you may. Nuclear is non-renewable because nuclear is not in the natural form. We have to perform whole experiment, right? Last time we discussed that it is non-renewable nuclear energy because we have to set up a plant, right?
What about hydroelectricity?
Hydroelectric. So
Yeah,
basically in
isn't it an energy
hydroelectric,
source too?
yes, also like the renewable energy. And we also mentioned hydropower. Okay. So basically there are multiple answers: biomass, hydroelectric, water waves. And what about the next part? Some methods of generating electricity causes much more.
Burning coal or something.
Okay, then wind energy. State one method of generating electricity that causes a large amount of global warming. You just mentioned something in the answer. Can you repeat again?
Me?
Yes, I think someone just
I
uh,
said coal, like burning coal for
burning
like
coal.
making steam and stuff. Yeah.
Yes, so burning fossil fuels, coal, natural gas. So,
Natural gas, yeah.
so these are the causes of large amount of global warming, right? Oil, natural gas, coal. So you already know about the names. So you may just write any one method. Secondly, describe in outline how the method you have chosen causes a significant amount of global warming. Now you need to write the cause or the name of the gas, like if gas is producing over there, or why, but why you think that this will cause significant amount of global warming. So you just
Uh,
need to
Produces
write
carbon dioxide, which is a greenhouse
carbon
gas or something.
dioxide. Very good. Carbon dioxide. Basically,
Yeah.
now you need to write the reason also that why it is causing such amount of global warming. So it will produce carbon dioxide. So it will produce carbon dioxide, and secondly, you may just write greenhouse gases, right? And next is during a 30-minute period, a mass of, okay, so initially time is given in minutes, mass is given kg of air enters the turbine with a speed of 15 meter per second. Speed is given. Okay, so basically you have to calculate kinetic energy, and Omer just mention in the answer and then remove, I think.
Yeah, my bad, my bad. Wrong recipient.
Okay, so 4.725 exponent 9. Okay, so let's check. Basically in question you already got the things. Time is given, mass is given, speed is given, and first of all they are asking about the kinetic energy of mv square. Mass is, so the answer I got in the chat from Omer is 4.725 exponent 9.
Yeah, because the proper answer is like
Yes,
4,725,000,000
yes.
Yeah.
joules.
And you know that we have to convert them into scientific notation, because that is the way to write the detailed answer. Okay, so that's good. First part is easy. Now in the second part, because they just mentioned the value of time, because they are going to ask about power also. In the formula of power we are having a concept of time. So first check the second part, then we will take the reference from the first part. Electrical power output. So they're asking about the output power connected to the turbine is. So this is the output power output. Calculate the electrical energy output from the turbine in 30 minutes. So you have to calculate the output in 30 minutes, right? Because what is the formula for power? Power is equals to
Electrical energy. No, no, wait. It's P is equal to.
work done over time.
Like a time
Wait,
for
for energy, it was electrical energy. It was different, right?
Basically, we just drive that
Yeah, it's equal to
power.
amperes.
VI
Yeah, current time voltage.
different, yes. But
Yeah, yeah.
the reference from the journal formula, that is P is equals to W upon T, or P is equals to E upon T, right? So they are asking about the energy. So we just write this formula as E over T, and they are asking about electrical energy. So energy will be equals to P times T.
Yeah,
So P is equals to
which is equal to the power. Yeah.
the given power, and then we have to use the value of time, but in seconds. So we have to convert that value. In 1 minute, we are having 60 seconds. We need to multiply 30 into 60 to convert that value into seconds. So what will be your final answer?
Wait. Okay, wait 1 second.
So I'm getting this answer. So
So I'm getting a different answer.
all you all of you are getting the same answer or different? Because you will get the answer in numbers if you are not using scientific calculator. But in scientific calculator, you will get the same exact answer in the exponents, 1.5 exponent 9. Okay. Any confusion?
Wait, sir. If
Mhm.
if E is equal to PT, shouldn't the formula be PT over T?
PT over
T, power into time over time.
basically power is equals to work done over time or energy over time, right? Because we are using same
Yeah.
units of work done in energy. So basically power is equals to E into E over T. So we just cross multiply T on the
Oh, you're trying
okay.
to find the we're trying to find the
Yes, we have to
energy. Okay, my bad, my bad, my bad.
yes. So basically this is sometimes confuses because all things are like same repeating input output in
Yeah.
power. So that's why we have to just check the formula accordingly. So you will get definitely the same answer around 1.5 exponent 9. Okay. And if we talk about the next part, so in third part, they are asking calculate the efficiency of the turbine. You remember the formula of efficiency, useful output energy or output power divided by input multiplied by 100. So they are asking about the efficiency of the turbine and the generator in converting the kinetic energy of the air to electrical energy. So we have to calculate the efficiency. So what is the value of input power and what is the value for output? Because in question, the output power is given, right? And the electric power output, yes, the electrical power output of the generator connected to the turbine is 8.4. And we calculated the energy output from the turbine in 30 minutes. And we calculated the kinetic energy because they are talking about the kinetic energy. So the value of kinetic energy is 4.7 exponent 9. And in the question, they give you the reference, a mass of this amount of air enters the turbine with a speed. So basically the kinetic energy you calculated. So is it input or output? The kinetic energy we calculated. Because in this question, you have to identify the correct part for input and output. If you just take the wrong reference, so definitely your efficiency will be always wrong. Because in question part B, 4.2 exponent 7 kg of air enters. So basically this part is input. Okay. So in part B, they are talking about the input energy and we calculated the input energy as 4.7. Okay. And in second part, we talk about the output energy. Okay. So this is energy output and this kinetic energy is basically input energy. Okay. Got the concept? Because when air enters it, because we are talking about the same question related to the windmill. So for windmill, air is the source. So basically, when air molecules hits the turbine or the propeller of the windmill, so that is the source of input energy, and that helps the propeller or turbine to move inside that windmill. So that will be your output energy. Okay, so you are getting input energy or the kinetic energy in the form of air. So that is input, and then you will convert that energy into output. So basically, the formula for efficiency is output energy divided by input energy multiplied by 100, and according to the values your output will be equal to. And you also know that if you still get confused and if you are not getting the right thing in your exam, so you may just take the reference like this, that your output will always less than input, because no mechanism will be 100% efficient. So definitely your output will be less than your input. So this is your output. This is your, so just divide 1.5 by 4.7, because exponent line exponent
31.9%.
3.9.
31.9, like 40% almost.
Okay. So basically 31.9 means round of 32. Okay. So we are getting round of answer 32%. Okay. And the next part is related to electricity because we are generating electricity. So we just skip this part for time being, right?
Yeah.
And let me check. Okay. So next part is also included. So basically next part, different energy sources are used to generate electricity. Energy sources are renewable or non-renewable. Nuclear energy is described as non-renewable source. Explain what is meant by non-renewable energy. So you just need to copy paste the definition again, right? Source of energy that cannot be readily replaced by natural means. Okay.
All right.
So we just need to write the definition in the first part, or you may just write those sources which are limited or that will run out shortly. Okay. So there are different ways to write the definition. And in the next part, four of the energy sources used are hydroelectric, oil, geothermal, wind. Write the name of these energy sources in the correct column. So there are three columns. First one is non-renewable, second one is renewable and caused by energy from the sun. Renewable and not caused by energy from the sun.
Non-renewable is oil, right?
Non-renewable is oil. Okay.
Renewable and caused by the sun. Oh, whoa, okay. A geothermal?
Geothermal in the second column.
Yeah. Renewable and not caused by the sun. Hydroelectric and wind.
And what about the wind and hydroelectric? First of all, hydroelectric, in which column we have to
Renewable and
The
not caused by
renewable
the
not
sun.
caused from the sun.
Yeah.
renewable not caused by the sun. Okay.
And the wind as well.
What about the wind? First column, second or third?
Third column.
Confirm.
Hmm.
Because
Yeah.
we are taking the wind as we need to count the motion or we need to consider the motion of the wind, right? Because when the air molecules starts to move from one point to another. So what do you think that it will caused by the sun or not? Because sun is actually providing the thermal energy.
Hmm.
So again, think of,
Oh,
might be you will change your
okay.
decision.
Oh yeah, the molecules and all. Maybe it's second column.
The second or third, that is solution that you need to finalize.
I
Okay,
said
so
second.
all of you are agreed on the second column
Wait, what? For wind?
for wind, because I just give you one
No,
rep.
no, no.
We
I
are
think
getting
wind is
energy.
renewable and not caused by energy from the sun. Third column.
Okay, so you are saying third column,
Yeah.
and one answer is for the second column also.
What? Oh, okay.
Anyone else that wants to define more about this? So basically, wind will be in the second column. I just give you the hint or the reference because we got thermal energy from the sun, right?
Yeah.
And when we will get the thermal energy, so basically there are gases in the air, right? So thermal energy just provide the energy to the molecules in air that will increase,
Oh, and that gives kinetic energy or something.
that will give the kinetic energy to the molecules, because wind is like the kinetic energy, the motion of the particles. Okay,
Ah, okay.
so that is the concept. So that's why wind in the second column, and all rest of the things are right. And next part is the state one way in which using nuclear energy is better for environment than using oil. And if you remember, we also discussed this point, that it will not produce like carbon dioxide gases or global warming. So we can say that less greenhouse gases, right? So you will get less greenhouse gases as compared to the other sources like burning oil, less global warming, right? So you may choose any point to this answer. And state one way in which using nuclear is worse for the environment than using oil.
Uses non-renewable sources.
They are only asking nuclear energy.
Oh, wait. Okay.
Basically, they are saying
Radiation.
that if we are using for electricity purpose, so why in which sense nuclear energy is worse for the environment than using oil? So yes, radiation. It will produce radiation and
Oh, wait,
radioactive.
but sir, does radiation harm the environment or like just humans in general?
For environment, you can say that radioactive waste, right? It will cause
Or it can
radiation.
enter the water? Yeah.
Yes.
Okay, okay.
So actually, that also harming your environment, because that radiations are going to be included in your atmosphere, and that will also cause all the problems with human beings, right? Part B is just a simple process of generating again electricity. And in this question, they just give you the boxes. Otherwise, they just give you the reference of complete diagram. So initially, we are having burner, we are getting thermal energy, we are having boiler, internal energy of steam. Then we are having turbine, right? So for turbine, we have to write the source of energy, type of energy, and finally, we are getting electrical energy output. So first of all, write down the name of the last component missing in the box. Because in question they are asking write the name of the missing part of the power station in empty box. So what do you think? What will be the name?
A generator or something.
A
Yes, a
generator.
generator.
So generator in the first part, and in second part is state the form of energy that causes the turbine possess. So the energy missing over here. So what type of energy you are getting from turbine or with the that is required for the turbine?
Mechanical energy.
Mechanical energy.
Yeah, we mentioned all of this in that question before.
Or kinetic. And you observe that there are three questions we found consecutive that is related to the energy flow diagram, right? The same process. Skip this part. This is related to thermal. Okay, so this topic, this question is also right. So this is the part of question from work energy power section.